Hey all, this is the first video in a series that I'm making. The series is going to be Applied Review, and it's basically just a way for me to review certain cybersecurity topics that I'm trying to get a deeper understanding of. The videos are pretty much for me, so I mean, they're not designed to be learning material, but if you find them helpful, feel free to let me know, or if you think I missed something or find something that I say that's maybe incorrect or just leaving out some important details, just let me know in the comments or send me an email or whatever, and I'll try to sort that out as best I can. But without any more dilly-dallying, let's continue here. Um, in this case, the SQL review is mainly based around the Portswigger labs. So Portswigger is the company that is in charge of distributing the Burp Suite software, which is I'm not sure the right way to describe it, but it's a like web proxy inspector. It lets you view HTTP requests and responses, but also has a lot of other really cool features that you'll actually learn about during the Portswigger labs. And I would strongly recommend going through them because this is only going to be a really straightforward simplification of some of the techniques taught in that. And then I'm going to take some of these things that it goes through and apply those to some CTF challenges that I've done or have partially completed, just because I think that's a good way to test things in a way that might not have a solution available to you or might just be a little bit more challenging for you. So we're going to start off by talking about what SQL injection is. I'm using this, this screen here, or this picture, I should say, to give a better understanding of, maybe to some of the beginners what SQL really is and how it might interact with a website. So somebody who hasn't made a website before, sometimes you might want to let somebody log into a website, and you don't want to store the usernames and passwords just in the clear text or the HTML of your site. So obviously, you're going to want to have some kind of database that stores that information. So your HTML might have some PHP code in there that wraps up the user input, let's say a username and a password, and it gets interpreted and sent to a SQL database or maybe a NoSQL database or just some kind of data store that allows you to ask whether or not that information is true according to your records, or maybe to just pull up some data or whatever you might want to pass things around for. And we'll go over briefly what SQL is, but it's just structured query language is what it stands for. And all that is the way that you ask a database for some kind of information, right? So in this hypothetical, let's say that we've got a store online and we want users to be able to, instead of looking at every single option in the store, maybe list by the category of the item that they might want to purchase. So let's say we've got a few categories in this table here. We've got, gifts, games, and tools, and you'll notice, each one of them has a name and maybe a price, and a Boolean value here to demonstrate whether or not the item has been released yet and should be displayed on the site. And so a typical SQL query might look something like this, right? Where you've got select star, which just means everything, from the products table. So imagine this, table here is the products table, and these different columns here are represented right here. So you'd say select everything from the products table, where the category is equal to gifts and released is true. So in this case, if we ran this query right, it would look at everything with category and everything with release set to 1, and it would grab those and maybe display those on the page for us to look at. And that's really about as simple as it can get. It could definitely be, you'll find examples, right, where it can be way more complicated and there's a lot more conditions, and we'll get into it towards the end of this. But let's talk about, what SQL injection might actually be, right? Because that's the topic of this. So let's say you're just a really avid shopper and you might want to know, hey, what are some cool unreleased tools that I might not have been clued into yet? And in this case, we've got a vulnerable web application in the case that the URI, or the URL parameter that passes the category, might not be sanitized or might just be passed straight through the query. So let's say that when you sort by the tools category, it shows you this, right? Select all from products where the category is tools and it's released. That might not have any inherent problems with it, but the thing is, we can kind of abuse the syntax of SQL to make it interpret the query language differently if we can control this input, right? So for example, like I just said, we could do this single quote, because remember in the last slide it's using the single quote on both sides, and these two dashes. And the two dashes together are just the comment syntax for SQL. So anything after those two dashes for the rest of that line aren't going to be interpreted by the database. It's just not going to, it's just not going to read that part of the query. And comments are important, obviously, for documentation purposes, but in this case, right, we're actually using it to look at items that have yet to be released. So we're completely cutting off this other part of the query and no longer making it needed. So now it's going to show us all the results from the products table where the category is tools, regardless of whether or not they've been released. So, and I know what you might be thinking, like that's kind of a really, really, really boring example. And you're not wrong. It is kind of a boring example. And we can think up some cooler examples, right? So let's talk about this, right? It's a username and password. So let's say this is your SQL query that you use to send a username and password through to your database. And if it finds an entry in the users table where the username is Gabe and the password is never going to give you up, it says, all right, well, that returns true, checks out, and you're authenticated to look at, whatever you're trying to authenticate users to. And I want you to just take a second, and I'll just wait like, maybe 5 or 6 seconds. And just think, how might we use that same trick from earlier to abuse this? And I'll give you a second. And then once you're done thinking about it, we can kind of move on. But this is one way that you could do it, right? If you know someone else's password or another username, you might not even need to know their password. And you could, also do it for the Gabe user if that's in there as well. So you could just say, hey, let's get everything from the users table where the username is admin. And then just use that same trick from earlier with the dot dot to comment out everything else, or not dot dot, whoops, the two dashes next to each other in the single quote to make it so that the rest of the query doesn't really get interpreted. And, in some cases, that might actually work. And we're going to talk about one of those cases right now that I've found in a CTF exercise on Hack the Box. The machine is Toolbox. I believe it's an easy Windows machine. Let me just pull up and double check. Sorry about that. My headphones died. I had to plug them in real quick so that I could keep recording. So basically, we've got our IP address, right? And I threw it into Nmap and just took a look at it, and we can see that there's an endpoint on HTTPS that's called admin.megalogistic.com. So threw that in my host file and went to go take a look at it. And when we go look at it in our browser, right, we are confronted with a login page. And given the name, right, admin.megalogistic.com, it's probably some kind of administrative dashboard. So let's just try to log in with, Gabe and password and see if maybe, okay, so it just tells us the login failed. And it might make sense if there's no real password. Let's try admin pass. Okay, so, in this case, it also doesn't even tell us whether or not that's a real user. We could try administrator. Whoops. And, we get the same thing. So we have no verification whether or not the username or password, individually is incorrect. But we're also not really given any way to, maybe brute force users or do some other weird kind of thing. So this is where we can kind of get into SQL injection. You'll notice, right, nothing weird is being submitted in the URL, which is good for them. But let's just try throwing in a single quote, and we'll see what happens, right? And interestingly enough, we get a pretty verbose error up here. And this error actually contains the whole SQL statement that we're going to be exploiting here. So you can see that PG query, which makes me think this is a PostgreSQL database, which we'll touch on later when we talk about enumerating the type of database and the version that it might be. But we also see there's an unterminated quoted string at or near that single quote that we put in. Let me just highlight all this so you can maybe see it. But you'll see here's the whole query, right? Select all from users, the users table, where the username is equal to, and this is really hard to see, but it's a single quote, and another single quote. So the username is probably inside of 2 single quotes, and when we input a single quote, it doesn't really know what to look for. And it says, and password is equal to MD5, and we don't even need to worry about the fact that the password is being a MD5 hash before it's actually thrown in, right? Because if we use that same trick that we just, hypothetically talked about, we should be able to just comment out the rest of this query. So, maybe we'll try administrator, single quote, and we'll throw the comments in there. We'll throw in some useless password. And it doesn't really work. Okay, well, let's try just admin. And, just like that, it passes us through to the dashboard of the admin page. So same thing, right? It's not doing its job and cleaning up our inputs, and we'll talk about prevention at the very end here, but that's just one brief example. I'm not going to go through this whole machine. I'm not going to do that for any of the quizzes here. I'm just going to talk about the parts of those machines that are relevant to what we're talking about. So that's one really straightforward, simple example, and we're going to keep moving and hop over back to our slides to talk about union injection. All right, let's move on. Before we get into actually the union attack stuff, we're going to want to talk about enumerating the type and version for a certain table. So you might want to do this depending on, well, I mean, there's a few things you might want to use it for. In some cases, right, in order to use some certain pieces of syntax, you'll have to know what type of database you're going to be pulling from. So like Oracle databases require, they have a few different interesting functions. Like later on, we'll talk about time delays, and those are really dependent on what database type you're pulling from. And like just earlier, right, we saw that it was a PostgreSQL database because of or we can assume that it was because of some of the debug information it displayed to us. And, this down here is a union select attack. Don't worry about union attacks. It's the next thing we're going to talk about, and it'll make a lot more sense. But this is just if you're enumerating for the version, maybe it's vulnerable to a couple CVEs, it might be useful for us. So um, getting the schema is another useful piece of information, if not just the version. And I describe the schema as just a map for a database. So if you don't know, like we did in our just previous example, the names of certain columns or the names of tables, you might want to have some way to get those. And if you've got, if you verified that it's vulnerable to SQL injection of some kind, you might be able to actually get that information. Now, the devil is kind of in the details here, and our previous attacks don't actually show us the content of this information, right? It either shows us something we shouldn't see based on a parameter that's not being evaluated, or it just, like the login bypass, it just sends us right over the wall. So that might not be what we're looking for, and that's where these union attacks come in. So we actually see this data that we're trying to get and disclose some information that might be more useful for us as we continue. So this query that we've got here is actually flawed and doesn't comply with the standard union syntax, or first I'll explain, kind of what this union keyword does. It allows you to have multiple select statements in the same line. And the use case for that is a little bit, it depends obviously on what exactly you're trying to do, but it's just for getting data from different tables that might have to do with one another. And the requirements are as follows, right? You need to have the same number of columns in both of the select statements that you're concatenating together. So if the original query is select the name and ID from the users table, this other select query needs to be it needs to be selecting the same number of columns from another table, so it fits that requirement, but it also needs to fit the data type. So in this example, right, it's name and ID from users and group ID and group name from user groups. And because of the order this is in, it might not actually work, right? Because ID is probably an integer and name is probably a string. So these are mismatched. And if the data types in both of these select statements and the number of columns don't match, you're not going to be able to do anything with that union query. It's just going to syntactically, right, it doesn't make sense to the SQL server. So it's important for us to be able to determine the number of columns that are in the select statement before we actually throw in our injected query. So let's talk about how you might want to determine the number of columns. And really, there's two strategies, and they both work equally fine. I personally think that order by can be faster, but union select is a little bit, you don't have to keep track of numbers. You can just go from one up, 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 and up. And now obviously, right, that depends on the number of columns. If you have hundreds and hundreds of possible columns that you could be sifting through, maybe union select is the slower of the alternatives. And order by is a lot easier to automate because you're just cycling through a number. But basically, what you're doing is, um, if there's a select statement before this, right, like select name and ID from users, when you say order by, it'll only return true if this number here is the number of columns in that original select query that might be off here to the side. So for example, right, if I have select user and ID from the users table, order by 2, it will try to sort those columns by the second column. So if we try to order by 3 in that query, it wouldn't work because there's only 2 columns. So you tell the SQL server, hey, can you order this by the third column? And it's going to say there is no third column, so it's going to return false. So that's one way you can remember kind of how this is determining that number of columns. And this does the same thing. It's the reason we're using null here is because null is readily convertible to all the other common data types. It's compatible, so you can just keep doing this. It's the same thing: 1, 2, 3, and for whichever one actually returns true for you, will be the one that we can use. And that moves us on to already, right, our second quiz. Let's do some union SQL injection. So in this case, I've pulled up the Jarvis machine from Hack the Box, and it's a medium difficulty Linux machine, I'm pretty sure. And you can just throw the IP address into your browser and get started doing the SQL injection if you aren't really trying to solve the machine and just want to follow along. So I've already spun it up in the background here between cuts, so that time isn't really accounted for, but we'll go ahead and continue and look at it. So there's a few different places on this site. There's a sign-in page. There's, dining and bar. It's like a hotel booking site, whatever. It's kind of cool. And the specific part I want to look at is the ability for us to look at different rooms. So there's, different types of suites here. And you'll notice, right, even as I hover over these at the bottom left, you see they're segmented by these ID numbers, which indicates they might just be, it might be a column in a database, it might be the actual ID number for the room or something like that. So, if I go into the URL here and I just change this to, I don't know, 5, because we saw 5 earlier, right? It brings us to this other room. So far, nothing out of the ordinary. If I throw a single quote, right, it doesn't work anymore, which makes sense, right? I doubt there's an entry called 5 single quote, but this also could just be some kind of error. And you would hope that they would throw some kind of error that doesn't let you know that this is SQL related. So let's try and see if we can use that same trick. We're not getting verbose information like we did on the last lab that's telling us, hey, here's the query that is having an error, and there is no easy way to tell that in this case. So let's try and see if we can do a little bit more to figure out maybe how many columns there are, so we could maybe create a query that adds up. So let's try doing something like order by 2. What I do want to do is throw a comment at the end just in case. Okay, order by 2 doesn't seem to help me out too much. Let's try maybe 8. Okay, 8 produces a blank page or an error page, so we know that it's somewhere between 8 and 2. We can try 5. Okay, 5 seems to work, and that makes sense, right? There's 6 total rooms that we know of, which is kind of interesting. Let's try 7 maybe. Okay, 7 seems to work. 8. 8 doesn't seem to work. Okay, so that makes me think that there's somewhere in this database, it's pulling from the select statement that prepends this order by statement that we've injected in. Has something, it's pulling from 7 different columns. And we can also do the same trick by using the union select feature. So it might act a little bit different. Because this COD is probably relating to the contents of one of these things. Or actually, you know what, let me just show you what I think. So we know that there's, at this point, using order by, we know that there's 7 different columns it's pulling from. Maybe one of those columns, maybe the first column is this image. Maybe the second column is this rating. Maybe the third column is, the title. Whoopsie. Yeah, maybe the third column is this title, fourth is this price. Maybe each of those columns represents some piece of data that's being thrown up in this, template for the room page. So um, if we don't want to mess with our information, we might want to change this. So let's throw it over to 0, which actually just brings us over here. So that's not what I'm looking for. But let's try doing the union select method. So we already know that there's probably about 7, but we'll try this. So if I do 1, regardless of how many I put in here, right? 7, 8, 9. It's going to give me an error regardless of if I'm right, because it's trying to get an actual entry. So if we throw 0 in, we know that 0 doesn't work, and now this doesn't work. But if I cut this back to like 6, still doesn't work. If I throw this to 7, we see some different behavior now that we have the correct number of columns here and an invalid ID number for the room. And it looks like, what we were inferring was a little bit right. So 5 looks like it's displayed where the rating tends to be, 2 where the room title tends to be, 3 looks like some area to store the price. So 3 is probably an integer or something like that, and 4, I think this was like there's like a tagline for the room. I'll actually double check here. So we'll just go back and look at 1. So yeah, so each of those pieces of data are passed through, or each of these columns, I should say, have a piece of information that relates to probably this lookup number that they're using. So maybe that's what this column 1 is, right? Maybe this first column is the ID number for the room, and these other pieces of data are what actually fill in the gaps on this page. But now that we know the number of columns, right, we can take advantage of that, and we can try and see which of these different pages or which of these different columns will give us a data type that will allow us to maybe enumerate the version or maybe start seeing data that we otherwise wouldn't have access to, right? So let's just try pulling from the syntax we already know. So we'll try and just do at version, right? And this is the syntax you use to query the version for Microsoft SQL or MySQL, which is an open source fork. And we see that doesn't really change anything, so let's go ahead and throw that in for 1. And we'll just paste it in 2's position. And you can see, it actually returned us the version of this database, right? It's a 10.1.37 MariaDB, and it even gives us information that it's one of the Debian builds. So right there, we just found out, okay, this data type in column 2 allows us to query for this version, so it's actually giving us something we can use. And you could even check this for even more of these different ones. So we could try 3. Initially, we might have thought it was an integer because it's a price, but it also seems like it's some kind of string variable or something else. Now I'm going to move it back to 2 because I find that, or maybe we'll switch it over to 5 here. Yeah, so that's nice and readable. I practiced this on 2, so I'll do it on 2 because I at least know we can read all the databases that we need, or all the information we need to see. Now, knowing the database version itself, right, it's not super useful to us. We're going to want a little bit more information. And for that, we can, like I said earlier, we can start looking for the schema name. So I'm going to duplicate this tab just in case we mess up really bad. But let's just start to construct some kind of query to ask for information about the schema. Now, we don't know the name of the schema here, and there could be a lot of different schemas present in this database because it might be used for more than one thing. So what I'm going to do is, before I even start getting the names of tables, I'm going to get the names of all the schemas that are available. And to do that, we're going to use the group concat command. And group concat will just take the different variables that are retrieved from this query and return them as a group. So I don't think the argument for this is going to be schema name, and we do need to specify what we're trying to pull from. So we can say that, give me all of the schema names from the default name of the schema table. So information schema dot. And this might change depending on, you might have to try different couple values for this, but schema.schemata will show you the different schemas if it's a MySQL database or a MariaDB in this case. And you can see it gives us the different names for the different schemas here. So there's the hotel schema, the information schema, the MySQL schema, and the performance schema. And you can go through all these and start looking at different columns and tables until you find what you want. For the sake of time, I already know that we want to look into the MySQL one. And the reasoning for that is, you could just peek into all the tables for these, and I'll show you how to do that right here. So instead of looking for the schema name, this time we're going to look for the names of the tables, because we want to get the tables in the MySQL schema. And instead of asking for the schemata, we're going to ask for the tables. And we need to specify, well, we don't want the tables from every single schema, and if we don't specify, it might not even give it back. So we're just going to say, where our table schema is MySQL. And we can go ahead and press enter. And oh, I might have messed something up. Did I spell something wrong here? Information schema.tables, where table schema is MySQL. Maybe group, tables name. That's a problem. It should just be one table. There we go. So obviously this cuts off and we can't scroll left and right. So I'm going to go ahead and open this page, or I should be able to view page source. And right here we can see all the different names of the tables that are present inside of the MySQL database. And you can see that there's a lot here. And you could go through and read the different columns in all these, but the one that we're going to do for the sake of time is the user table, because let's be honest, the user table sounds the most interesting. It's going to tell us information about different users. Maybe we'll get some passwords and stuff in there. So let's go ahead and try and look at the variables, or goodness, not the variables, the different column names as part of this. And this is where we're actually going to utilize more of the group concat command, because we're going to want to know we're going to want to have some way to separate them. So let's just say table name, and we'll separate the table name with a colon, and we'll say column name. So this way, when it concatenates the values, instead of just being table, 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 it'll be table, colon, column name, table, colon, column name, and it's all going to be the same table name, but you'll see what I mean in a second here. So we'll just leave it like that. And we do need to specify that it is from where table schema is MySQL, and the table name is user. We've still got those comments. Okay, we'll try that. Oh, I messed something up again somewhere. Let's see. Column name, table name from information. Oh, that's where I messed up. This should be, we're not pulling tables anymore, we're pulling columns. There we go. So you can see we get the table name, column name, table name, table column, etc., etc. There's a lot of different columns in this table. And obviously, right, these two look pretty interesting. User, password, maybe host if you're interested in that. So, let's go ahead and just try and dump those individual values from there. So, we can just do, let's say we want user and password, and we don't even need to specify all this stuff anymore because we have all the information we need to drill it down. We should just be able to say from MySQL, the schema dot user, which is the user table. So now that we're saying, just show me the username and password columns from MySQL user, just show me the information from there. And in this case, we get a username and what looks to be a password hash, or maybe a really good password. And we can verify that. You could do this if you want to. We'll go ahead and throw it in CrackStation and see if it lets us crack it. And it looks like it does. It's a MySQL 4.1 hash. And if you didn't, if for whatever reason a hash you have doesn't work in CrackStation, you can always go on the Hashcat wiki or just do some Googling and figure out what type it is and crack it on your own. But that's how we can actually enumerate the type and version and actually look at different values in one of these vulnerable pages that's vulnerable to SQL injection. And we just walk through the different union attacks of first verifying the different numbers of columns to actually reading a database value. So let's take a break here and we'll hop over to blind SQL injection. And now it's time to talk about blind SQL injection. So this is, in my opinion, one of the more tricky versions, you can call it, of SQL injection to catch. And that's mostly because you can't really see detailed responses. So where our previous attack, the union attack, kind of relied on us being able to see the results of those queries, blind SQL injection attacks are defined by the fact that we actually can't see results of our queries. So you'll normally have to find some other indicator that the logic that we're submitting in this query is either valid or it isn't. So sometimes this can be a strange response that you get back. Sometimes it can be a conditional error. So when a certain condition in the query is fulfilled, you'll see a different error message that's not very verbose, but is still something. Or if you're able to, and my favorite of these, just because it seems cool, is triggering time delays and using the time delay in the request and response getting back to you as the way to determine whether or not your query is executing. And that might sound a little bit abstract right now, but I'm going to try and make it make more sense. So imagine you've got a website, right? Web application, and there's a tracking ID. And if this tracking ID, is passed through this query, this is in your request header. And your tracking ID is used to determine, whether or not the website determines a little welcome back banner when you navigate to the home page after logging in. And let's say this imaginary web application is vulnerable to SQL injection, so it uses this query here. And this query would be, you wouldn't be able to tell what's changing unless you pick up on the absence of the welcome back banner. So what we would have to do is send two different tracking ID cookies that both have an injected value. So again, like we have before, right, we break the syntax here, and then we'll say and some condition that's undeniably true, right? 1 equals 1, or something that's undeniably false, 1 equals 2. So in this case, if you were to submit a valid cookie and then 1 equals 1, because it returns true, you should still see the welcome back arrow when you come through to the web page. And in this case, if it's false, you should not see welcome back. So you can use these to determine, okay, this query is being executed in both cases if I have a valid cookie, or if in both you don't have a valid cookie. But you can use that to verify whether or not this this condition is true or false, and in the response, if the response verifies whether or not this condition is being evaluated. And there's other examples that we can use, and you can actually use this to brute force certain values if you're savvy with either Python scripting or Burp Suite. Or I'll show you during the lab how we can actually determine certain values. I won't go into too much depth because we'd be here for maybe upwards of 45 minutes. But if that happens, so be it. But that is something you can do in these circumstances. One of the other options is conditional errors. So it's the same circumstances before, but instead of trying to trigger a response, we might try to trigger an error. So this statement here will try and trigger a divide by 0 error that you can see. So let's say that in both these cases, the cookie is valid. So in this one, right, in the case where it's false, then do this. So it shouldn't, this first case should do nothing. And if adding the A to some statement evaluates to A and doesn't throw an error, then you'll know that this is being evaluated. And then you would also test this. And if you see that the divide by 0 error message shows up, so a very unique error message appears, or some kind of error message that you haven't been able to trigger with other input occurs, then you might notice, or you might be able to use that to actually verify the fact that this condition is being evaluated. In this case, just instead of using the presence of that welcome back in the response, you're just using the presence of this error, either in a verbose error message that it's giving you that's just telling you it's trying to do a divide by 0, or some other kind of error that might be occurring. And you can actually utilize stuff like this to brute force characters. So at the end of the legitimate cookie, and we say and select when username and the substring command we'll talk about. But let's say it's comparing the username administrator in the users table, um, and if it evaluates A, in this case, well, actually, let me talk through it a little bit different. So this substring command, all you need to worry about is it's checking to see if the first character in the password is equal to M. And if it is, what will happen, I think, if I'm reading this right, if the first character is after M in the alphabet, then it will throw a divide by zero error, and otherwise it'll evaluate to A, which shouldn't cause any problems. And because of that, you can use, okay, if I get a divide by zero error, then that means that the administrator, the first character of the administrator's password is an M. And you can do that for every single index or every position of the password until you have a complete password. So it's effectively, kind of like brute forcing, except you do need to actually, I don't know, you get the idea. It's brute forcing, but to an extent. And then the other option that we can do, and I think this one's pretty cool, is triggering time delays. So same thing, you can just end the current statement, or if we've got the cookie in front of this, however, and if false, wait for this delay. So let this happen. You shouldn't get any delay here. And then if true, wait for delay 10 seconds. So after sending the request and getting the response, if you see this delay for 10 seconds, you can verify that this condition was correctly evaluated, and then you can use that same kind of feature to figure out what the characters in a password are. So this would be a little bit more tricky to program in with Python or Burp Suite, but it's definitely doable. It's definitely something that you would be able to do. So you would just have to, you can maybe make the delay a little bit shorter depending on your connection speed and stuff like that to the endpoint. But it does the same thing. It takes the username, administrator, and substring, so the first character in the password, and if it's after M in the alphabet, it will wait 10 seconds before replying. And if that gets executed, you can be sure that this condition that you supplied is true. But now that we've kind of got that worked out, all that's really left to do is to go through this last quiz that I've got set up that we could go ahead and do. So let me pull up our Kali Linux machine. Now I've already pulled up this web application. I've already captured some requests in Burp, but we will go ahead and start over just for the sake of this. So this machine is called Intense. It's retired. It's a hard Linux machine, and I've already signed in as guest. There's a few things that you can do on this machine. One of which that you do before this step actually is dumping some of the source code that's used for the web application that gives you, at least for our purposes, some names of both an administrator user that we know of, but we also have the guest user that we know of, and the presence of certain tables that we can actually start looking through, which is really fortunate for us in this case. So this site lets you submit messages for feedback, and you can capture these requests in your repeater. So if I were to send hello, right, we get the OK message, and I can render it real quick and actually make this a little bit larger if I can. So we get an OK response if everything is expected. If I were to insert like hello with a single quote, you'll notice it says, unrecognized token. So we're kind of getting some idea, okay, well, it's putting our hello in single quotes here, and it doesn't totally understand what this is happening. So we know that there's some kind of error, but it's not spitting back any part of the query. It's not spitting back any extra data. So it's blind SQL injection in the sense that we can only really use these conditional errors to derive any meaningful information. So same thing, if I just submit this single quote, I don't get anything super useful, right? I just get this tiny piece of information that doesn't really help me. So this is something that we can do. Load extension A, I believe, doesn't do anything. I might have to revise this, but I believe this just throws an error. So when, instead of it giving me some verbose error message, it just says I'm not authorized to perform this action, which means that, the web application isn't authorized to do this action, which is good. The fact that we can produce an error that's not unrecognized token, or I think there's one that we can do if we just do like HEL, That might not work. You should be able to get it to do an error if you have too short of a message, but that might only appear on the, yeah, so that only appears if you do it in the front end. Um, but that being said, we can do these OR operators are just meant to concatenate the end of whatever function we inject into, um, so that we know that if the condition before this is true, or if it's false, it should execute this regardless. Um, that being said, now that we've verified the presence of some kind of error, we can actually, using these conditional responses, figure out certain things. So I'll kind of walk through this query one at a time. So we already know the username, the users column. So select the username from the users table where the username is like. So the like syntax is just starting with G and continuing with %. So we know there's a guest user. So this should return true, but keep in mind, if this initial part is true and this throws an error, then we should still get an error if this initial condition is true. So you'll notice, not authorized. And if I, make up a username, so I doubt anything starts with like a, I wonder if the pound sign will work. Yeah, so I doubt there's any username here whose username starts with the pound sign. And it says OK. So it's kind of backwards. It's not giving us an error when we're wrong. It's giving us an error when we're right because it's executing that error and our information that we can verify is correct. So if I were to type GU, we should get not authorized, which is true. EST, we know there's a guest account, so this should be not authorized, meaning there is a user whose username is like guest something. If we were to put 1, you'll notice it returns OK. So we can actually use that functionality as you would think, right, to figure something out. So we could do like, if we think there's an admin user, okay, there is someone with the first, okay, A is correct, D is correct. Let's try N. Nope, no N, but M. Admin, okay, I, N. Let's try admin. Let's see if it's administrator. Nope, it must just be admin. Yep. So that's how we can go about enumerating usernames with this blind SQL injection, which I think is pretty handy, even though it's a little bit more complicated. And we can also, just because I want to showcase it, we can do the same thing with time-based SQL injection. So you'll see at the very bottom right of my screen when I send this request, you see the time in milliseconds it takes to respond, or it takes from me sending the request for the response. And these are nice and quick. If we want to do it, and again, I prepared some of these statements ahead of time, but the web application, the code that we have to debug through before doing any of this, has a few words that it whitelists out. So we can't use functions like exec sleep or sleep. I don't even think is included in this. At least when I tried it, I wasn't able to get sleep to work. So what we had to end up using was, I'll just show you here. So let me go ahead and scrap this. And I ended up doing select the hex. Whoops, it's supposed to be. And we'll just say, I think, we'll just throw a bunch of zeros in there, as long as it's a number that's large enough that we can notice it. Oop, I think, okay, I got both, okay, that's fine, that's fine. Where username, like, let me make that capital so we can distinguish that that's syntax. And let's say username like G. So we know there's a guest user, we know that that's actually a real person. And then we should be able to, let's see, I think select the username like, I think I might have one too many parentheses here. I might not, let me find out. Incomplete input, okay. Okay, so in that case, you'll notice, right, the request we had before that took way less time. Let me actually throw just one more zero in here so we can see. If I do something like pound, like we did before, let me make this a little smaller then. Okay, so that's as big as it gets. But you see the response time, 292 milliseconds, real quick. But when I change it to a username character that we know, like G, and I press send, you'll notice it takes an extra, 1,000 milliseconds on average. And I can do this over and over again. It's like 116, 1051, 1152, etc. But as soon as I change this to like admin I, pretty quick, 300. Admin. So again, we're using the obviously we have to do this one character at a time for anything legitimate. And thankfully, you can use burp macros or you can use some Python scripting to actually automate a lot of these processes, but it's still useful information to keep in mind. Um, so again, that's kind of just a good example of blind SQL injection in a way that you can verify usernames. If you want to do this machine, and I won't do it here just because it'll be time consuming, but you can actually brute force the password using this method by either, like I said, setting up a burp macro and incrementing the word list that you're testing each time, or by using a Python script, whichever you find easier. But you can do it with these automated statements, and that's how you're actually, or I believe that's how you're supposed to get the foothold for this machine to continue. Um, but I think we've just got a little bit to wrap up. So we'll go ahead and continue with second order SQL injection. So this is kind of a bonus item. And basically, instead of our query being executed like right when we send the request, it might be requested on another page. So, imagine you've got some kind of website that has it recommends pictures based on your preferences or something. And so you have to go to your user settings and update your preferences before you'll see those changes reflected on that main page. So that if your preferences are an injectable parameter, you might be able to actually store that query that you've injected, and then when you go to that home page where it processes that query, will you actually see some kind of difference happening. So second order SQL injection just means that you really just have to make a couple more requests before the query is getting utilized by the web application. So there's a demo for it that I wanted to do, but it's for a machine that is still active right now, and I don't know of any other machines that have a really good example. So once that machine retires, I might go ahead and just throw that in here retrospectively, but it also depends on how much time I have. And last but not least, right? We want to learn how to prevent these things. It's not really useful unless we know how to stop this from happening. So really, there's two things you can do, and it's trying to separate user inputs from your queries and sanitizing those inputs when possible. So there's plenty of countermeasures and web application firewalls that will stop you from putting single quotes or double dashes or even those characters in the inputs because they know you're just trying to mess with it. But that by itself isn't really a good idea because if somebody can XML encode their payloads or URL encode it and get around your sanitization, then you might run into some problems where you still have insecure queries. And that's where these are sometimes called prepared statements or parameterized inputs, but they all effectively do the same thing. And you just separate this user input from, like, for example, the string that only has one argument, so you're only supposed to have this one input, and then that gets passed through to the query. So instead of me actually manipulating the query itself, I'm manipulating some other variable that's being passed through to it, and I can't, really extend this past what it's built with. So just keep that in mind that that's really like the prevention method is that you can prepare these statements in such a fashion that I'm not able to add additional information. But you should still try and, like all the other good things, don't show error messages, don't make sure you sanitize input as much as you can, and all those other safekeeping things. But aside from that, that's really all that I've got planned in this video. If you've got any questions or think I could have explained something better, feel free to let me know. But otherwise, have a good rest of your day.